Scalar quantities. Welcome, strangers. So, scalar somethings. Scalar quantities. This is something with a size. Yeah. Scalar quantities. This is something with. Scalar quantities are something with a size, also known as a magnitude. Area. Okay, let me list a ton of scalar quantities and explain them a bit. Area. Area is the measure of the amount of space available. You know, commonly you'd use centimeters squared, or meters squared, or kilometers squared, or something. Miles squared, sure, why not? Imperial units, sure, why not? Distance. Distance is how far traveled. Meters, centimeters, kilometers, miles. Energy. Energy is the capacity to do work. This is normally measured in joules. Temperature. Temperature is how much kinetic energy a substance has. We normally measure this in degrees Celsius. But if you're American, then it's Fahrenheit, right? Isn't there a really cool book about Fahrenheit? Obviously it's not about the measurement, but I might read it. Time. Time is not only the fourth dimension, but it's a noble attempt at managing to quantify how long the events occur. So the duration, yeah? Duration. Mass. Mass is stuff. There was a science explainer for that kids show, the kids talk thing in a science museum, and they were like, mass is stuff. Yeah, I agree, mass is stuff. Speed. Speed is how fast something travels. Okay, so these are all scalar quantities. Obviously this is a small selection, but they are scalar quantities. They have a size. They have a magnitude. Magnitude means, drumroll please, size. Yep. So distance is a scalar quantity in which only the coverage of the athlete matters. So how much distance did the athlete cover? That's all that matters. Even if the athlete does a whole lap and lands at the exact same spot in the end, the displacement would be 0 meters. But if it's the same track as last time, then the distance covered would be about 600 meters, give or take. Yeah. See you next time at Physics in Necrotic World. This is your host, Rimona Christian, R out.